Okay, let's get started. So my talk will be about benchmarking and why I think it's a very important key to safe and secure AI. And safe and secure AI is something I think a lot of you care about, but it's also something I care a lot about, especially in recent years. So, as most of you know here, Norway has very ambitious goals for AI. So most of you have read the digitalization strategy, I guess. Who did read it? 1, 2, 3? Okay, that's more than usually. So I would recommend to read it because it's kind of an interesting perspective on what Norway should do in the digitalization. AI has a big part there, and also so AI has a big part there. Security, I think a bit decoupled from AI, but it's connected. Infrastructure, which is important, like our own large language models and so on. Data, so everything is kind of connected, and a lot is also connected to benchmarking. Also, this year was the first time I could vote in the Norwegian election, and I watched a lot of the debates the politicians had, and I was really surprised and a bit shocked that for most of the difficult answers, like how should we solve the problem that we will have very much old people in the future in a society, and then it was like, oh, AI and robots. How do we solve this very difficult problem? Oh yeah, AI, we just ask AI and it will give us a solution. So I think there's kind of a misalignment with what AI can do and what people think it can do and what they want to use it for. And I think this misalignment is maybe also connected to how these AIs are benchmarked and also how these benchmarks are presented, because no one really knows actually what does this number mean. If an AI is good in, I don't know, LM arena, what does that really mean? Is it actually a really good model? What does it tell us? And that's something I want to talk a bit about today. So yes, I think that for like a really safe implementation of AI in the society, we need to have evaluation is one of the biggest problems, I think. Maybe some people disagree. Some people think it's very boring, especially engineers. They usually implement first, and then they measure at the end. And then they say, OK, it's good enough, let's go. Or even worse, we don't need to measure. We just let the users test, and then we see how it goes. It's an important part of benchmarking to use user tests, but it should be the kind of the way to go as a standard. So evaluation in general, I think, is a bit broken. We need to do more work on it. We need to really well understand how these models work and also what concepts they understand. Like how good are they, for example, in different ethical questions, but how good are they, for example, in Norwegian, and so on and so on. And I think especially, for example, the language technology group from University of Oslo is doing a really great job there. But we will hear more about it later. And then, of course, there are other big topics like AI alignment, which I'm not meaning like this alignment of AGI in the future killing humans, but more like cultural alignment, practical alignment, and so on and so on, reliability and trust, and also sustainability. How do we actually measure how much resources a model uses compared to what we get from it? Is it worth that we can ask ChatGPT about how to cook, for example? Yeah. So this big question I usually ask everyone is, what do you think how AI can be really beneficial for society and so on? We will not go into that because I have a lot of slides, so we'll run out of time, I guess. But there are important things, like we want to make capable, safe, trustworthy AI. It should address societal challenges. It should adapt to society. Like we have to adapt to it, but also AI should adapt to us. It should be responsible, blah, blah, blah. It's a lot of different kind of nice goals for the future. But how do we actually know that we managed to do that? So how do we know that, OK, now we have a model that is better aligned to our Norwegian cultural values? How do we know? Now we have a model that is better in following clinical practices in Norway for medical analysis. How do we know? How can we really measure that? And that's very difficult to measure. So it's maybe a big claim, but I think building AI systems these days is very easy. So you can build like, I don't know, retrieval, augmented generation, or RAG-based system in 2 hours, something like that. And you get something up and running, especially when you use AI to help you. So it's very easy, but I would also say it's very difficult to build good and useful AI systems. There's a lot of, yeah, I don't want to say the word, but bad systems out there. I would call it, I think I like this term AI slop. It's usually used for badly AI written text, which is very obviously AI written, but I think we can also use the same for everything related to AI that is done sloppy in a not very useful way. And also, it's really important to understand that an AI system today is not just a model. So if we talk about ChatGPT, for example, it's not just GPT-5 or whatever is behind there, a combination of GPT-4 and 3 or something like that. But it's way more. You have a system prompt, you have some embeddings you do from your documents you ingest, you have a search, you have tool use, you have some guardrails where someone decides what the LLM should answer, what not. You have the user interaction. So it's a very complex system. And what we often measure is the only thing that we often measure is the outcome at the end. We don't measure the different parts. We don't understand how the different parts connect. We don't understand even how, if you have a multimodal LLM back there, how the different modalities influence each other and so on. So it's very complex. So these two examples here is something that I think most people these days want to use practically, but also in research you see a lot of it. The first one is a RAG-based system, so you have some LLM, and then you build some search that helps you to get some documents in there, because then we hope that hallucination is gone and so on, which is not really true. It can help a bit for that. But if we take that system, we do not only have to test the model, but we also have to test reasoning. If we use a reasoning model, we need to test accuracy, relevance of the information that is retrieved, and so on. So there's a lot of things that we have to test for such a system. And then if we go into the next thing, which is kind of, everyone heard about agentic AI this year because everyone talks about it. So their evaluation is even more complex and even more complicated, because suddenly we have not just one system we test, but we have several kind of subsystems that interact with each other. We need to test them. They maybe use their own tools, their own RAG implementation, and so on. So this whole thing is just a big, complex mess, you could say. So, okay, that was the wrong direction. Yeah. So, what is the goal we actually want to achieve? We want to have a safe and trustworthy AI. And that means it's not just enough that we get told, okay, our AI is PhD level intelligent, can solve everything. It doesn't mean anything. Especially, we need to understand what impact does this system have on the real world. And that can be a bit meta, like what ethical and what political views the LLM has, for example, or the AI system, but also more practical, like how good does it this task here that we specifically defined. So we want that it's accurate, of course, and reliable, without doing some harm. That's important. I think everyone agrees on that. I think we have to really focus on ethical governance, global collaboration, because that's kind of important for the society. We cannot just slip these systems and then hope they are okay. And it should be aligned with human values. And all of these things is difficult. And how we benchmark this, I think, is very challenging and not a solved problem. But why is this important? Because these systems are everywhere. I mean, I have AI on my phone. You get it on your computer. You get it everywhere. I think even on my fridge has AI. So it has real-world impact. It means it does something. It has impact on our children, for example. If you heard about the latest cases with OpenAI and Meta, where they had, their AI systems gave bad advices to children, which led, for example, to suicide. We don't want that. Why did no one kind of find out in the testing that this could happen? That's kind of that's really related to trust, democratic concerns, everything around culture, we're kind of eroding our culture, and also the practical differences. And I think that benchmarking is really an important part here. So if we go a bit back in the history of benchmarking, it's not new. And I think for a lot of people, like when I started studying, and I had my first kind of course that was related to measure something, I was like, that's boring. Why do I have to do this? These days, I'm really excited about benchmarking and measuring. I think it's one of the cool things you can do. But it was boring. So I think we also, in education, we have to work on at the universities and so on. We have to make this subject more interesting to people, because it's very exciting. But it's not new. So we could say that it started maybe earlier than 1950s, I'm sure, but the Turing test is one of the earliest benchmarks, I would say. Everyone, I guess, here knows what it tested. The question is, so some people say it's solved, some say not. Who here thinks the Turing test is solved? 1, okay. 2, 3. Who thinks it's not solved? 3. Who thinks it's complicated? Okay. Then we had over times, especially I think the earlier benchmarks were a lot about images. We had MNIST, for example, digital digit recognition, and then we had ImageNet, which was kind of an interesting step because suddenly we had millions of data points in the data set. So ImageNet was actually one of the large data sets I started working with, and it was very exciting because it had millions of images, so it was hard to process back then. We didn't have everything prepared for us. We had to kind of program on the GPU ourselves, and it also had a lot of classes, so it was very interesting to use it. But you could also back then already see that it was limited. Also a key thing we followed over time is this train-test split. So everyone is familiar with that. We have some parts of the data, we use it for training, and then we have an even smaller part of the data and we use it for testing. And then basically when we have done the test, we say, okay, this model is good to solve this task, and then we maybe start using it. So that's kind of how we did it up until now. And then, of course, here are mostly image examples, but then we also have a lot of benchmarks for text and other modalities. Multimodality is also coming more now. So I think we are now have a bit of a crisis in this kind of old way of doing evaluation. So why is that the case? And this is kind of related to LLMs, but I think this is also true for kind of, I don't know, traditional AI. Like if you just built an image recognition system that uses convolutional neural networks to, I don't know, detect cancer in your colon, you also have similar problems there. So it's not just because we have LLMs. So what happens? First of all, we have a lot of more data going into the models. That means these models have seen a lot of more data, which means that the small kind of amount of data we use to test it is most of the time already presented somehow in the data set, especially for LLMs if you have a lot of data in there. So we have a contamination problem, which also makes this split a bit of a problem, because if you have trained on 99% of all the knowledge, or even more, and then you have a tiny data set to test and to use that to verify if the model can be used or not for some tasks, this is kind of not representative of the reality, and also it's kind of a contamination problem. So we kind of have this, we train for everything, and then we test for one thing, and the tests we create are often very small and not representative of the reality. Of course, there's a need for these small tests, because what you can do with these small tests is we can decide, okay, can this model do this task? For example, let's say we take a model that is trained on ImageNet. If we take the model, we do a training on ImageNet dataset, we do a test on the 20%. We can say, okay, the model appears to be good at classifying images. But that doesn't mean that the model now can be taken out into, for example, a hospital and suddenly do classification of cancer images there. There's still some gap there, some real-world gap, because we cannot really all the data sets we have for benchmarking now, if it's 1,000 images or 1 million images or 5 million images, they're not really representative for the real world. The real world is much more complex, it's much more noisy, a lot of things happening there, there's a lot of things we don't know, there's often missing data and so on. So it's a challenge. Yeah, contamination problem, I already talked about, and that you can imagine a bit like, let's say you're studying for exam at the university, and then someone has leaked the answers before, a set of answers, and then you do the exam, and some of the answers appear in exam, some maybe not. So you kind of already have seen the questions and answers before, and this, of course, will give you an advantage. And that can also happen with our models. And there are some interesting studies which show that a lot of, so there was one study from 2023, which showed that 15% of this human eval benchmark was actually in the training data of some LLMs. So that means the LLM has already seen some of the data, which means that basically you could say as soon as a benchmark is released, it almost gets useless. So I would say that the most interesting numbers we can get from the benchmarks we see today is actually the thing that we see at the very start when they are fresh. And of course, some maybe do this on purpose. They want to kind of play the game because it means a lot if you're number one on the benchmark. But this can also happen without intention because you maybe have a huge data set you use to train your model, and you cannot look through all the data there. Could be that there was some data of a benchmark there that you didn't want to have there, because I don't want to say that people do it on purpose to cheat. Some do for sure. But you know, this gets so massive and so complex that it's really hard to control for everyone, also for myself. Okay. And then we have leaderboards or arena benchmarks. Are most of you familiar with that? Yeah? So what you basically do there, you have some kind of, people thought, oh, let's do it a bit more interactive, which I think is a good idea. So it's a bit like chess. You have, you would have LLMs competing all the time on different questions, and then you give them a score, like ELA score, and then based on that you rank them. And how they do it is you have the platform, and then people get, for example, 2 answers from an LLM, blinded, and then they could decide, I like this best or I like this best. And then you do that for a lot, and you kind of get the score. Interesting idea, I think very useless, because what does this really show us? We don't know. It could show us that what do people like, what kind of answer style do they like? Do they like polite models? Do they like more strict models? Do they like models that are factual and so on? So that's a challenge. It's also challenging because these benchmarks are biased. For example, 60% of the answers, or the 60% of the use in LM Arena, for example, is OpenAI or Google models, and the rest is other models. So you can already see it's not kind of a fair comparison. Also, big companies can easily take these answers there and immediately put them into their models and improve them, which, for example, smaller open source models cannot do. Another challenge is that a lot of these models are depreached. And why does that happen? Because some people or some companies, or also open source models, they make models specifically for the benchmarks. So for example, a good example is Llama 3. So they made different versions of Llama 3, which was specifically trained for this kind of LM Arena benchmarking. And then, of course, it scored quite high. The original Llama that wasn't trained for it did not score high. And then it was there on top, which was good for them. They got kind of some PR. And then, of course, they didn't want to continue the model. And then it depreached. So I think around 200 models that are there in LM Arena are depreached without really being marked as depreached. Only 40 or something are marked. So someone is gaming the system. And that, of course, is good for them because, you know, for the marketing and for the money making and for investment, this means a lot if you're on top there. So usually if you see a new model coming, you have some big shot in the company talking about, oh, we are, in this benchmark, we are number one. In this benchmark, we are this. Then they often also make weird graphs. So if you remember, for example, GPT-5 announcement, it was quite interesting how they presented how good they are, even if they were not, which was, if you're an undergrad student at the university, this would be the first things to learn, how you should not present your results, because it's kind of misleading. Okay, and then, like one of my favorite topics, you also have multimodality, and that makes the whole thing even more complicated. Because if we put multimodality into it, it gets very difficult to measure. Because it's easy if we just do a benchmark for images, or if we just do a benchmark for text. But then if we start to combine the two, it kind of gets complicated. What do we actually measure? How do we measure the impact of the image part and the text part, and so on? There are interesting question answering benchmarks where you're given an image and maybe some questions, and then you ask for the results based on image and text, but also there you kind of, it's a bit vague and very complex. So I think that's also something to take into account. I just need to check when do I have to stop? 45, okay, still good time. Okay, so how do we go from here? So everyone agrees that this is kind of broken, or is someone like, no, this is perfectly okay, we should continue like that? No one? Okay, then I can continue. Okay, so what can we do? Oh, here's actually a practical example that I wanted to show why this is actually important, that we dig deeper into the benchmarks. So this is from a paper. At the end of the talk, there's a list with all the references. So this is a paper where they wanted to do medical question answering. So what they had was basically an image, some question, some choices, and then they wanted the LLM to answer. And then they compared it to doctors. Very popular thing to do in the medical domain at the moment, because they want to show that our AI is much better than the doctors, so that they can sell to the hospitals. So it kind of showed, yes, the AI was on par, sometimes a bit lower, but better than the doctors. But if you looked more detailed into the behind, so what actually really happened, you could see that the reasoning of the models were actually wrong. So it kind of gave the right answer for the wrong reasons, which, for example, in the medical domain, is not a good thing, because you don't want to have a model that maybe gives a right answer but didn't understand anything. It shows that something is wrong. What did the model actually learn? What did the model actually do if it gives the right answer for the wrong reason? Okay? Did it memorize something in the data? So there's a lot we would need to understand before we could actually put that model out in a hospital and start using it there. Yeah, here we can see some. Here you can see some of the accuracy, especially. I'm always very skeptical if you see something like 100%. So that's like, okay, this benchmark you can just forget, don't trust it. But you can see kind of the hidden flaws, the test they did there. The paper in general is not very good, but I think it's very interesting that they kind of find this problem here. Okay, then there's another benchmark from OpenAI, Health Bench. Anyone heard about that? Yeah? So they kind of wanted to, I think what you can see with OpenAI now, for example, there are many others too, they're kind of trying to push a lot into the medical domain. And that, of course, makes sense because there's a lot of money there, there's a lot of need, because we actually have a problem to give the care to the people that need care, here in Norway, but also in other countries. So they, of course, want to do something there. And that's kind of related to another problem when they come with their own benchmarks. So what are they doing? They have some. They took some doctors from different countries, which is good, and then they gave them questions to solve, and then the doctors had to go through the questions. Like it's kind of question answering task, but over several turns. So it's like the doctor first asks, okay, how you feel today? Or you come to me and you say, oh, I have a headache. And then the doctor would ask, okay, what did you do yesterday? And then you have some turns. Some of them have only one, and so on. So, but the idea is that you kind of, it's more realistic. The doctors ask over time, and it kind of should be more realistic. Then they did also some categories and some Rubik generation, which I think is maybe the most interesting outcome of this, because this was approved by over 200 medical doctors from all over the world. So these Rubiks could be interesting for future work. The benchmark itself, I did some analysis on it and wrote about it. And it's kind of interesting if you look into details in the data, how weird it is. So for example, they claim it's a multi-turn benchmark, so it should have a lot of multi-turns. Actually have, most of the questions are single turn, so it's just a simple one question, one answer. And the more turns you get, the less data points you have. And here, that here would actually be the interesting part, which is the most realistic. That here, we already have a lot of benchmarks that do something like that. And then, if we go even deeper in the benchmarks, and that's something, if you're very interested into this, I can recommend you that if you start using a data set, try to go into it and look at the data. And I would not say 100% sure, but I'm 95% sure that you always will find something weird and wrong. And here, some interesting examples. So this one here is, for example, first turn start was, is Megan Carley's mom a mutant too? What does that mean? Or, I supervise an 11-year-old who is interested in gardening. So there was no medical kind of connection there. Or, how much flour to use with 2 cups water? So you have these questions in a benchmark for medicine, approved by 200 doctors by OpenAI. How can that happen? There's something wrong here. This is also, even have some pornography. So I don't know if someone actually looked at the data, or they could at least have done the kind of, I don't know, ChatGPT looking at it and find these cases. That could be easily done. But it's not, everything is not lost, luckily. There are some interesting papers coming up. I think this came now in the summer, which is a benchmark called MediQ from Allen Institute for AI. And they kind of try to make it more interactive. So what they have is kind of a patient, and that goes a bit into agentic AI. And I think here we have to be a bit careful, because I think, as you will see later, it's important that we get more interactive benchmarks. But at the same time, all the interactive benchmarks I see now that are kind of interesting are a way to sell in some agentic system where you not really want to benchmark the medical application, but you kind of want to show that, oh, look, I can make this fancy agentic AI where it can do all these things at the same time, which could be very practical, important for the clinic. It's kind of a mix, I think. If you read the papers, you will see what I mean. So what they're doing, they basically have an AI and a kind of a gate so you have a patient, the expert, and the expert can ask the patient questions. So you don't get everything thrown at you at once. You don't get like a case report where it says, you have this and this data here, you should answer this and these questions. Because often if you ask the questions, you already kind of imply the answer. So this here is more open. You don't know anything. You have a patient, you can ask questions, and you can come somewhere with this or not. What is also really interesting with this benchmark, it also gives plus points to the system if it says, I don't know. And that's kind of unique. More and more benchmarks come up for this abstention, but this is kind of unique. So if the model is unsure, it should actually say so. And then it gets a higher score by saying, I don't know, I cannot give you an answer, I don't have enough information. So if it, after several turns, still doesn't know, it will say, I don't know. Or then it gets a higher score, which I think is interesting. So it goes more from a static to interactive. They also have the data set published. So on Hugging Face, you can actually look at the data. And it's kind of a simulation, which you will also see later. I think is interesting. It measures, and that's also a thing we have to think about. What do we actually measure? So what they try to measure is, of course, diagnostic accuracy, whatever that means. quality of the question that is asked, and also if it did appropriate, say, I don't know. And I think, of course, this is not perfect. It's an agentic system. It's, if you ask doctors about it, they have kind of flawed meanings or different meanings about that it has some flaws and so on, which I think is important to look deeper into, but it's a good start. Okay, so how can we do this right? I know I will come up with some suggestions. So as we know, an AI system is very complex. We have an application need, so we build these systems usually for something they should be used for. We have some system in between where we have data augmentation, model training, evaluation, explanation, user feedback, we have system prompt, there's a lot in there, as I said at the beginning. And then we have the users, and then usually we also want to give feedback. So it's complex. So, principle one I suggest we should follow is that we have a very systemic approach to evaluation. That we not just treat evaluation as something we stick on the system at the end when we are done, or maybe once in the middle, but we do it from start to end. When we collect the data, we already have to start evaluating the data, like you saw with the OpenAI benchmark. If you want to start using the OpenAI benchmark, a clever thing would be to first really look at the data, and then remove the cases that are bullshit. Or maybe don't remove them, but treat them so that you actually know these are bullshit questions. I should kind of account for that in my benchmarking. Data augmentation needs to be tested. Here also embedding is interesting if you talk to practitioners that building rec systems, and then they are like benchmark using, for example, Ragas, which is a framework to do that. They benchmark like how good is the question answering and so on. And then you ask them, did you benchmark the embeddings that you use? Do you know how well they work? Do they work well, for example, for Norwegian input text and you asking in English for output and so on? Did you benchmark this? And then they're like, no, why should I do that? This is kind of magic that works. I downloaded it from Hugging Face and I trust it. So there are components in the AI system that need testing while we're building it. That's important. So you can almost think it like we have an inner loop of testing and we have this outer loop. And then, of course, model training, model evaluation itself, I think also model evaluation gets more complex. So if you try to use, for example, some benchmarks from LM Harness or so on, there's so many knobs you can turn. It's kind of getting an own training process in a weird way. So it's very important to also take that into account. There's actually a very good initiative. I can share a link later where people actually, a lot of international people work on something they call evaluation cards. So they want to kind of make, model cards. We have dataset cards, but they also want to have evaluation cards. That every model comes with an evaluation card where the evaluation is detailed, described, following some principles. It's open for everyone to join, so if you are interested, I share the link later. And then, of course, explanation is important. Explainable AI was quite hyped. Got kind of forgotten a bit with LLMs coming, because now we can't just trust AI systems. But I think it's also very important to still continue trying to understand what the models are doing, not just for LLMs, but everything else, and also include it somehow in the evaluation process as a thing. User interaction and feedback, I think that's also very important. And then, of course, there's a lot more. Prompts, system prompts, guardrails, your rec system, and so on, you name it. So there's a lot. So the important thing is that you have really a systematic approach to it, and that you start from the start to the end, already have a plan, what you want to evaluate, when, and how. And we're not there. So I think there's a lot of practical questions how to do that, but also research questions. Principle 2, and that's very difficult, measure what we actually need, what actually matters. A 99% accuracy score is meaningless if the 1% is actually that I care about. If you make so one of the rookie mistakes I made when I started doing machine learning, I worked on a project where I analyzed sensor data, and then I made this model. I was like, wow, 99% accuracy. I'm like the new machine learning god here. Until I understood that there were very little cases in the data set that actually mattered, where people actually had the disease. And my model did not find those. So my model was basically useless. I could just have said no to every question and could also have 99%. So it was a very rookie mistake. But I think even if it's a very rookie mistake, and maybe a lot of you here in the room will say, I would never do that, I know this. There are a lot of people that do these mistakes in academia and also outside. And the easier it gets to build AI systems, the more we also see these kind of rookie mistakes emerging, again, because people don't care a lot about evaluation or don't understand it. I think also that it's kind of, these traditional metrics like ROG score, BLOI, and so on, they are important for different parts in your kind of approach, how you benchmark the system, but they are also often insufficient for real-world tasks. And maybe they are sufficient, but we don't really understand how we should connect them. So if you get, for example, let's say medicine, if you have a precision recall and maybe F1 score, what would it actually mean for your deployment? Do I need the high precision? Do I need the high recall? So there's a lot of things to kind of, we need to understand, we need to do research, and we also need to connect. Yeah, 5 minutes, okay. And also, I think a very important question, which I often get asked from practical people, is what number is good enough so that I can deploy my system? So if I use, I don't know, if I use accuracy, what number can I use so that I can actually put it in my clinic and then people will not die or something like that? It's a very difficult question because that needs clinical testing, that needs interaction with the people that are actually working in the field and so on. So that's it's difficult, and I don't know the solution. For some problems, I know how to do it. For others, I don't know at all. So I think we need more research there, and we also need more kind of collaboration between disciplines. Yeah, I'll jump a bit over this, because most of you will know this because of the time. Also this, you can look at that later. There's an interesting benchmark, because I think that especially LLMs don't answer a question. That's actually very interesting for me, that we get more kind of this awareness of uncertainty into our models and also in the systems. And this is a quite new benchmark, which is called abstention bench, which basically benchmarks that. So how well does the model say that it doesn't know, which I think is very interesting. I think there are some general rules we can follow, of course. There's no one-fits-it-all metric. So if you read an article and they present just accuracy, it's not good enough. They always need a set of metrics, and they should kind of make sense how a metric you can almost imagine like it gives you different perspectives on the performance of the model, and for some use cases you might need more perspectives than only one, and usually you need more than only one. So you always should have a set of metrics. I also think that we should do more iterations, so not just do run, and then be happy, but to do more iterations and to look at the variance and so on. I think there are a lot of good evaluation frameworks out there, and also benchmarks, which we should start using and build up on. For example, we will hear more about the benchmark from Language Technology Group for Norwegian. Also, manual evaluation is still important. We still have to pick kind of pain points or injection points where we can actually and should look at what's going on manually, not just rely on the metrics, but also do kind of this sanity check in between. And I also think it's a never-ending process, especially if you think about AI systems these days. If you build an AI system that should, for example, I don't know, let's say National Library, who builds an LLM for Norway in Norwegian, they make a model, and then someone builds a ChatGPT kind of platform on top of it, and then we deploy it. It's not done. It's a continuous process. We would have to measure how does it evolve over time, how does it react to user input, and so on and so on. We would have to collect these cases, the very difficult cases and important cases we would use to make a very difficult data set where we can benchmark on, and so on and so on. So there would be a lot of, it's a continuous process. It's never ending, basically. It's like a living thing that you're not get rid of. Yeah. And principle 3 is kind of make it interactive and dynamic. And there we can, I think, get a bit inspired by gaming, because If you design benchmarks a bit like games, where the questions are open, you measure kind of decision-making, reasoning, and so on, instead of giving a set of answers and questions, this can be more real-world kind of related. And we have some interesting examples there. So there's a Pokemon benchmark. Did anyone hear about that? Yeah, some of you. So that was kind of first used by Anthropic. I think it's a very interesting benchmark because there you kind of let an AI system play Pokemon and you see how far it comes. And then you kind of measure a lot of interesting things like decision-making over time, taking into account space. There are a lot of variations of Pokemons. There's a lot of complexity there. So I think it's a very interesting benchmark. It's not perfect again, but it can be a good kind of interesting idea to build benchmarks on. So make them interactive and dynamic. Some practical tools and frameworks. I think you can also look at that yourself because of the time. And then we have the humans as the gold standard. Are humans really still the gold standard? I think, yes, they are. But, of course, everyone builds AI systems these days, so it's very hard to use these people because they're used for a lot of things already. So you kind of get this, oh, do I have to be part of another AI study where I answer things? So we should also be very careful about how we use these humans, especially if it's in expert domains, if you think about medicine, for example. In the old times, so when I started working on machine learning, we used crowdsourcing to collect data, to do user studies, and so on. I think these days, you can forget about it because crowd workers basically use ChatGPT to provide answers. So then you can just use ChatGPT via the API and do it yourself. This, I think you can also look at it. Of course, there's always pro and cons for using humans and not. And then we have a very interesting kind of thing, which I'm personally a bit critical, is using LLM as a judge, which is, of course, a nice way to get a quick evaluation. I have to admit, I have used it myself when I didn't want to use a lot of time on the evaluation involving humans, because it gives you a quick some numbers where you know, okay, it kind of looks promising. But I think it's a bit dangerous because you don't really get what you think you get. You don't get this deep human kind of thinking and perspective on the problems. You get AI slop evaluation. So it's AI slop evaluation. Can be useful for some quick things. Can be not useful for others. The example I had here, this one here, I used ChatGPT or GPT-4 API to find these cases because, of course, I didn't want to read through all, I think, 9,000 data points in total. So, and for sure, there are some missed ones, I'm quite sure. So if I would have looked it through it myself, I would have found even more. If you let the doctor look through it, they might have found even more weird things there. Yeah. So the question here, I think, is, can and should we have AI evaluate other AIs? And also, sometimes for me it's weird if you, for example, OpenAI has a new version of their models and then they use a previous version of their model to test their own model. You also get this bias in the models that is kind of spilled over here. And also I think it's kind of interesting thought, I don't know how you would do that, is kind of, can we make infinite benchmarking? Can we make benchmarks that are never stop and have an infinite, not really infinite, but a lot of possibilities that you could never kind of exploit before by looking at the benchmark or training on the benchmark. I think the Pokemon benchmark is kind of an interesting way in that direction, but it's of course not perfect because I think there's still some ground rules that you could learn, and then you kind of can play the whole game. So it's not infinite different possibilities. So in summary, where do we go from here? I personally really believe that how well we are able to build safe and trustworthy AI systems is directly linked to how well we can measure them. If we cannot measure them, we cannot say anything about these systems. We can maybe have a hunch. We all know these cases where people like, oh, I tested this on ChatGPT, look how well it works. And then you maybe tested yourself, it didn't work. Because there was a large part of the conversation that was not provided. So it's this, oh, I tried this and it looks okay, this is not good enough. I also think that the traditional benchmarks are failing for kind of the complex systems, but I don't think they are useless. We still need them for this kind of inner loop testing, especially on the engineering side. And I think we have to push our students and colleagues and so on more on the benchmarking. So if you have a colleague that doesn't like benchmarking, try to convince them to do more benchmarking or testing. And I think the future has to be systemic, so we should really take it as part of the design when we do these systems, nuanced. What really matters has to be measured, and this is difficult to kind of understand what does really matter. There we have to work together, and it should be dynamic. And that's it. Thank you.